Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Dear students, in our previous session we discussed acids. Let's continue our topic, acids, bases and salts. Let's have a recap. Acids are those substances which are sour in taste. There are two types of acids, organic acids and mineral acids. Organic acids are obtained from natural source, plants or animals, and mineral acids are obtained from minerals. They are obtained from non-living things by chemical means. Okay, so we cannot taste all acids because these mineral acids especially, they are very corrosive in nature. They can cause blisters, they can cause burners, so we cannot taste them at all. So for testing a particular substance, whether it is acid or base, we have indicators. Likewise, we yesterday discussed litmus test. Indicators are those substances which when reacted with acid or base, they change their color. Okay, litmus when come in contact with acid, the red litmus turns blue. Similarly, when blue litmus turns red, a particular substance is base. Now, there is China rose. The petals of China rose are pink in color. We extract the juice of this China rose, that is light pink in color. When we extract the juice of this China rose, it is a flower. The petals of this flower, the juice of this flower is extracted, so that a solution is made. That solution appears light pink. When this light pink solution of China rose is a substance, when its color changes to green, so that particular substance is basic in nature. So when the color changes to dark pink, so therefore the substance is acid. You got it? So this is another indicator that we commonly use, that is China rose. When the light pink color of this China rose solution turns green, the particular substance is base, and when this light pink color changes into dark pink, then the particular substance is acid. Similarly, we have another indicator, that is phenolphthalein. Okay, this is an organic dye which is colorless. It is having no color. So when this colorless solution comes in contact with base, its color changes to deep pink, and when it reacts with acid, there is no color change at all. The solution remains colorless. So by these means, we can say that a particular substance is acid or it is base. Okay. Now, what are bases? So bases they are bitter in taste and have soapy or slippery touch. Bases are those substances which are sour in taste and have slippery or soapy touch. Okay, like sodium hydroxide. You will find this in soap cakes especially. Sodium hydroxide. This sodium hydroxide, it is a base. Similarly, potassium hydroxide. You will find this potassium hydroxide in liquid soaps, like ease, which is used to wash the sweaters, the woolen cloths. So potassium hydroxide is present in this liquid soap. Similarly, we have calcium hydroxide. Calcium hydroxide, it is present in lime water. So this calcium hydroxide, it is also a base. So similarly, there is magnesium hydroxide, what we call, it is milk of magnesia. Milk of magnesia. So these are some common bases. So we can recognize these bases by taste. So if there is bitter in taste, so therefore a particular substance is base, and these bases have soapy touch. But all the time we cannot taste acid or base by this very method, bitterness or it is sourness. We have these indicators, by the help of indicators, we can say that particular substance is base or acid. Okay, now students, you have learned what are acids and what are bases. So I will recap once again. Acids are those substances which are sour in taste, and bases are those substances which are bitter in taste. Now there is a concept what we call alkenes. Alkenes, acid and base. Alkenes. Dear students, we have another way to define acid or base. We have alkenes, acid, alkenes, base. So any substance when mixed with water, when dissolved in water, if that produces H positive ion, that is acid. Okay, and if a substance when dissolved in water produces hydroxide ion, OH negative ion, so that particular substance is base. So therefore, when we have a look over these bases, they when dissolved in water they produce OH negative ion. Okay, and acids like HCl, HNO3, when dissolved in water they produce H positive ion. So this is another way to define acid and base. Now students, we will discuss physical properties of acids and bases. Physical properties of acids and bases. Number one, now first of all it is acid. Acid is first. What are the physical properties of acids? Number one, acids are sour in taste. Okay? Acids are sour in taste. They turn blue litmus to red. Blue litmus turns red in acid. Acids are of two types, organic acids and mineral acids. These mineral acids are corrosive in nature. Mineral acids are corrosive. Number fourth, most acids are soluble in water. Most acids are soluble in water. So this is another physical property of acids. Most acids are soluble in water. Soluble in water. Dear students, acids are good conductors of electricity. Good conductor. Good conductor of electricity. So these were the physical properties of acids. Now, physical properties of bases. Bases are bitter in taste and have soapy or slippery touch. This is the first and foremost property of base. Bases turn blue litmus to red, and mostly bases are insoluble in water. These are physical properties of bases. Now, dear students, we have neutralization reaction. What is neutralization? When an acid completely reacts with base. When an acid completely reacts with base to form salt with the evolution of heat, that is called a neutralization. Okay, like NaOH. This is sodium hydroxide. Sodium hydroxide is a strong base. When this sodium hydroxide, it reacts with HCl. HCl is hydrochloric acid. This is mineral acid, strong acid. So when this strong base reacts with this strong acid, acid base reacts with acid, we get salt. NaCl, sodium chloride, and H2O and water. So this is a neutralization reaction when base reacts with acid, a salt and water is formed with evolution of heat. So that is neutralization reaction. We find neutralization reactions in our day-to-day life. You might have heard about indigestion. In our stomach, there is a juice, gastric juice. This hydrochloric acid in dilute form it is there. In our stomach, this hydrochloric acid in very dilute form is in our stomach, which helps us in digestion, in process of digestion. When we take spicy food, so we feel a kind of acid in our stomach or in our mouth. So that is because of there is much secretion of this hydrochloric acid in our stomach. So what a doctor advises us, he gives us magnesium hydroxide, magnesium hydroxide. So this acid, it is neutralized by this magnesium hydroxide and we get relieved by this acidity. So therefore this is also a neutralization reaction. Another example of neutralization reaction is soil treatment. So we use these fertilizers, mineral fertilizers, inorganic fertilizers in our fields. So by that our soil develop acidity. So the soil get acidic in nature. But for proper growth of plants, the soil should be neutral. Okay, when we continuously use these inorganic fertilizers, the nature of soil get acidic, which is not good for growth of plants. So what we do slackered lime. This slackered lime is added to soil. This is base. Slackered lime is base. So this slackered lime, it neutralizes the acidic nature of the soil. Okay, and the soil get neutral, which is good for the growth of plants. Another example is sittings of ants. When the ant stings you anywhere, you feel a kind of pain. Why? Because that sitting of ant contains formic acid. HCOOH. The formula of formic acid, HCOOH. So that sitting contains formic acid. What we do? We paste that sitting with soap, with toothpaste. So that because soap contains sodium hydroxide, which is base. So this base neutralizes the effect of the sitting of ant. Okay, so therefore this is also a neutralization reaction. Similarly, we have factory wastes. Factory wastes are acidic in nature. So before allowing these factory wastes in a particular water body, these factory wastes, they are neutralized because the acidic wastes are very harmful for aquatic life. So therefore there is a proper mechanism to neutralize these acidic wastes. After that they are allowed in a river or in a particular water body. So this is about what we learned today. We learned acids, properties of acids, bases, properties of bases, indicators, different types of indicators, and we learned neutralization reaction. Okay, thank you very much.